Question 14, Part B. Consider the hyperbola y equals 1 over x and the circle x minus c in brackets squared plus y squared equals c squared, where c is a constant. Part 1. Show that the x-coordinates of any points of intersection of the hyperbola and circle are zeros of the polynomial p of x equal x to the power of 4 minus 2cx cubed plus 1. The x-coordinates of the points of intersection of the two graphs are found by solving simultaneously the equations y equals 1 over x and x minus c in brackets squared plus y squared equals c squared. And we're going to solve this by substitution. So if we look at the second equation, we have a y squared, and from the first equation, y is equal to 1 over x. So we can substitute 1 over x for y here in the second equation. So we get x minus c in brackets squared plus 1 over x in brackets squared is equal to c squared. Now 1 over x in brackets squared is equal to 1 over x squared. And so we could multiply all three terms by the square of the denominator, which is x squared. And that'll eliminate this fraction here. So we get x squared outside of x minus c in brackets squared plus 1 is equal to c squared times x squared. So expanding the brackets on the left-hand side here, we get x squared outside of x squared minus 2cx plus c squared in brackets plus 1 is equal to c squared x squared. And then multiplying through by x squared, by multiplying the x squared to all the terms inside the brackets here on the left-hand side, we get x to the power of 4 minus 2cx cubed plus c squared x squared plus 1 is equal to c squared x squared. Now we can cancel c squared x squared from both sides of this equation. So we get x to the power of 4 minus 2cx cubed plus 1 is equal to 0. And I've labelled that with an asterisk. Hence, the solution of the equation labelled with the asterisk correspond to the zeros of p of x equals x to the power of 4 minus 2cx cubed plus 1. Part 2. The graphs of y equals x to the power of 4 minus 2cx cubed plus 1 for c equals 0.8 and c equals 1 are shown. By considering the given graphs, or otherwise, find the exact value of c greater than 0 such that the hyperbola y equals 1 over x and the circle x minus c in brackets squared plus y squared equals c squared intersect at only one point. Let's consider the graphs of y equals x to the power of 4 minus 2cx cubed plus 1 for c equals 0.8 and c equals 1. Now the dashed curve here corresponds to c equals 0.8 and the solid curve corresponds to c equals 1. Now where the curve touches the x-axis, that corresponds to exactly 1, 0, which means exactly one point of intersection of the hyperbola and the circle. So what we're looking for is a value of c such that this stationary point here, this minimum point here, touches the x-axis but does not cross it. Now, being a stationary point, what we're looking for is the value of the first derivative of x to the power of 4 minus 2cx cubed plus 1 to equal 0, but we also want the value of the function itself to also equal 0. We want to find c such that the equation p of x equals 0 has exactly 1, 0, which corresponds to exactly one point of intersection of the graph with the x-axis. So from the graph, the value of c will lie between 0.8 and 1, and the value of c will be such that the minimum stationary point will touch but not cross over the x-axis. In other words, it'll bounce off the x-axis. Hence, we want the value of the first derivative, p dash of x, to equal 0, and we want the value of the function itself to also equal 0. So letting p of x equal x to the power of 4 minus 2cx cubed plus 1, the first derivative p dash of x is equal to 4x cubed minus 6c x squared. And factorising out 2x squared, we get p dash of x is equal to 2x squared outside of 2x minus 3c in brackets. Solving 2x squared outside of 2x minus 3c in brackets equals 0, we get two possibilities. We get x is equal to 0 or x is equal to 3c over 2. Now if we test x equals 0 using our function here, p of 0, we get 0 minus 0 plus 1. We get p of 0 is equal to 1, which means that it does not touch the x-axis. So therefore x equals 0 is not a solution. So if we test or consider x is equal to 3c over 2, we get p of 3c over 2 equals 3c over 2 in brackets to the power of 4 minus 2c outside of 3c over 2 in brackets cubed plus 1. Expanding the brackets here, we get 81c to the power of 4 over 16 minus 2c outside of 27c cubed over 8 in brackets plus 1. And that equals 81c to the power of 4 over 16 minus 27c to the power of 4 over 4 plus 1. Hence, p of 3c over 2 is equal to negative 27c to the power of 4 over 16 plus 1. We get this fraction here by combining these two fractions together, by finding a common denominator. Now what we want p of 3c over 2 to equal 0. In other words, 27c to the power of 4 over 16 equals 1. And we want to find a value of c by solving this equation here, or making c the subject. So multiplying both sides of this equation by the denominator 16, we get 27c to the power of 4 equals 16. Dividing both sides by 27, we get c to the power of 4 is equal to 16 over 27. And then taking the fourth root of both sides of the equation, we get c is equal to the fourth root of 16 over 27, or 2 over the fourth root of 27.